Welcome to this tour of the top event-driven pitfalls. I came into contact some collection of war stories from different companies. I want to send a message instead of doing a REST API call. What can possibly go wrong, right? That's the topic today. So the introduction, we're going to have to say goodbye to the direct call stack lifestyle that we are used to since high school, since school, some of us. There is no more you waiting for them, so you will send a message. You don't know when it's going to start processing, you don't know when it's completed, you don't know if it failed, and what are the errors if it failed. And you don't know whether it's completed twice. What do you mean twice? And what do you mean the message get lost? What do you mean the message got lost? Where is it? Fun. My name is Victor, 18 years of coding, Java champion. I'm doing right now full-time workshop for companies all over Europe. And I get to talk with people from all these domains like banking, e-commerce, telecom, transportation, so on. But the best thing in my life is that I can talk to very bright people from all these companies. You can imagine in such a workshop, they give their best people, so then they can spread the ideas further to the others in the company. And as a give back for this opportunity, I compiled these talks, put them online as my legacy. There you go. I just gave legacy a good meaning. Nice. So I have a webinar. I'm also doing monthly webinars for my community. Feel free to join. And I'm trying also to have a live. So let's start with the naive assumption that the consumers are gonna process the messages with a single thread. Now, I am gonna use the terminology from Kafka today, but all the love for the rest. The things that this was the most difficult part really today, to compile some lessons that are applicable for all these technologies. Most of them, not all. Right? So the naive approach would be to think that your messages are consumed sequentially by a single thread. This is, of course, absurd in terms of throughput. It's going to hurt your ability to do more work, right? So it never happens, basically, unless you ask for it. But it's a pitfall that, yeah. So what we usually do, we have multiple consumer instances within the same consumer group. Fun, all good. Now, pay attention here. When I say consumer today, I mean thread. Those threads could run on one machine on multiple machines. Any Spring fan club in the house? Spring concurrency. There is a listener concurrency thing you can set. If you set it to 3, you run 3 consumers on a single pod, on a single instance. Now, this consumer group basically causes competition between all the consumers. And that can lead to very surprising moments. So, for example, these consumers belonging to the same consumer group, right, might be incorrect to share the consumer group if you deploy a blue-green version. If you want to test the new version, do you want the green deployment to steal messages from the blue deployment, right? Or if you deploy a shadow deployment just to check up what the results would be for the calls that we are tapping into the production stream of calls, not doing anything, not returning back to the user, just comparing the results of the old and the new. Perhaps you upgraded to Java 25, who knows? Then, in this game, do you want the shadow deployment to steal the messages from the production system? Probably not, right? And one of my favorites, when your colleague starts their machine, they steal messages from the dev environment. Beautiful. And you're there waiting for the message in your environment. Where the heck is my message? On that colleague's machine. Another story here. This is very fun. I can't get into all the details, but someone that called me for a consultancy asked me to debug a false failure. Basically, if you start Spring integration tests, there will be multiple instances of your Spring application running side by side, kept in what they call context cache. The slides will be available for you, all the links work. And that is going to make multiple instances of your application running side by side in your freaking unit tests. And then you should see some flaky testing. Green, red, because the message that you expected to reach the mocked bean in your application lands in the other application connected to the same Kafka running in memory or in a test container. And it basically routes the message into the wrong thing. So one idea would be to assign each instance of Spring a different consumer group when you're testing. For example, good morning. So we're gonna talk about SIM. SIM cards inside. There is a thing called prepaid SIM. You have to charge SIM before you can activate an offer. That's the domain we're gonna have most example in. And here are 2 messages coming into on the same queue or topic. landing on a consumer group, basically the client for this SIM ID charged twice. Once it gave €5, it charged 5, and then charged 3 more. What can go wrong? Easy. They can not charge. I'm trying to keep up with the current credit value. They can be that you can lose one of them. So both of them go to the database, which has 0 now. In the end, should be 8, right? Both of them read from the database. If they now have in memory the old value, they add to that value what they want to add, and they write over each other in the database, therefore losing 5. Classic story, right? So what should we do for this? The easiest thing to imagine is to use optimistic locking. What does that look like? You're going to attach a version into the storage you have, bring the version in memory, and when you write it back, you want to make sure that you are overwriting the version you think you are overwriting. So the second one here fails, saying optimistic locking error, for example. What should happen after an optimistic locking error? Easy. Retry, perfect. So the message broker or the consumer is going to retry the message immediately, reading from the database the new value 5, adding 3, it's down to 8. Yes, problem solved. Done. Optimistic locking. Now, one warning here, do not even try to do pessimistic locking. Do not even think of trying to delay a consumer until the previous one has finished working. This is going to hurt performance throughput, and it's going to may lead you to have deadlocks. And debugging a deadlock when those threads run in the background, it's a joy. How would you know? And you have to set alarms for consumer lag or for how far you are, what's the queue pending to process. And if you see them stalling, maybe raise an alarm. Difficult in practice. Now, let's aside the story in which the messages race each other. Let's think about two messages coming in. One adds €5, and the next one tries to activate an offer with which you can speak for 1 month for €5, for example. Now, message 1 arrives in, and then message 2, so in such a scenario, if M1 is sent and then M2 is sent, how can M1 start after M2 has finished? This can be a bit puzzling. How the hell did that happen? Well, producers sent these messages. They are in a queue, one after the other. Now, for increasing throughput, all the message brokers, all the drivers will fetch a batch of messages to each consumer. So technically, this is split in 2 batches. The green consumer takes the first batch, the blue consumer takes the other batch, and now you see how the blue consumer starts on M2 even before M1 comes into play. Very easy, right? Prefetch or batching in Kafka, this is what we're talking about, right? Prefetching in Rabbit, batching in Kafka. So the realization here that we have to make is that order does matter only between a subset of your messages, only between the messages that pertain to the same SIM ID in our case. I don't have any ordering to enforce versus other SIM IDs. Does this make sense? Give me one hand, just one hand. Does this make sense? Partitioning for the win. Excellent. Now, this is very easy in Kafka. It's one of the work styles, but it's interesting to do in Rabbit. But if you manage to plug in a single thread to one of these subset of messages, the problem is solved, right? So you have to split messages in partition in logical queues. How does Rabbit do it? Well, you could have an exchange splitting the messages by a routing key into queues and then plug a single thread per each queue. It's difficult. You can do it, but it's difficult. And then the idea is that you hash the message key, right? And you assign it to a certain partition based on message key, routing key, ordering key, depending on the technology, right? So now all these two will be in the same partition. As long as there is a single thread processing that partition, nothing can go wrong. There will be no race condition, there will be no scrambled order. However, good luck finding a key for this message. What if I transfer from a SIM to the other? What would be the key to partition this message? Ouch, because it touches on 2 aggregates. Which one should I tap into? On what partition should that land? That's a more interesting question, right? Now, this idea of bringing messages in to preserve their sequence will push you, it's an incentive to store in the same queue multiple types of messages because you want to preserve their relative order. So you're going to tap into and send different types of messages within the same queue or topic. So that's one way to solve the out-of-order messages. There are 2 others, sequence number and delayed retry. Now, With sequence number, it goes like this. The producer attached to every message they send a sequence number. So for this sim ID, I'm up to sequence 3 right now. The message comes into the consumer. The consumer remember that the last sequence they saw for this sim ID, and if it came in 3, but the last one was 1, then what will it do with this message? M3, what happens with M3? It's gonna wait. Where do I wait for it? With it in memory? No, I'm gonna store it in the database to keep it safe, right? And then when M2 comes to the party, I'm gonna pick M3 from the storage after I process M2, and I'm gonna finally, eventually, execute M3. So you buffer them somewhere for recovering the sequence, right? Smells of TCP/IP, yeah? Anyway, the point is that how long do you keep this message until the correct sequence arrives? Are you okay suspending it for minutes? How long, right? And what if, just 2 weeks ago, someone told me, yeah, we did that, but sequences had gaps. What if there's no 2? What if there was never a 2? And it keeps going with 4 and 5. What do? Then you have to make a trade-off here, right? How much can I postpone emitting the message and processing the message further versus, so basically it's a trade of latency delay versus consistency. What is the size of my sequence, by my resequence window, right? So, but this is just a dream, guys. In most of the cases, producers have a very hard time emitting consecutive. How the hell do you do that? You can't use the sequencing database because those can have a rollback. So what do you do in there? It's going to be very difficult. Usually that works only if you have a kind of counter in a machine through which the request gets routed. Or like imagine an API gateway through which all the calls come in. That single instance can have an atomic integer assigning per sim ID. Very hard, very hard. So that's why the third solution could be the best. The consumer might try to process offer activated, trying to activate that €5 offer, and that will turn into an error. That error would make the message retry. But if I retry the message without, so you see, the offer activated is here, but behind me, it's the correct message trying to add credit first. So in order for me to succeed, I have to process the message behind me. How the hell do I do that? If I keep retrying the one in the top of my queue, it will not help, correct? It will not help. I have to get my hands on 2. 2 is out of order. It's sitting behind me. So what should I do in that case? It's called delayed retry. You send one somewhere, and then that one would come up for a while back in the queue so that you get to see other messages in the meantime, right? So you get to see that credit added. A debate here is how long should you delay this retry, right? When should you give up? What do you do after it times out? And please do not reinvent your wheel over here. Use retriable topic in Kafka Spring, or use delayed send with Rabbit. Search for your own infrastructure, how it allows you to solve this problem. And if it doesn't really allow you anything, you could insert the message into a table. It's called the inbox table, and pull from there any failed messages that failed more than 5 seconds ago. Make sense? Ew, brother. Ew, brother. Am I reinventing Rabbit? Good. Nice. So these other 2 we saw just now. Now, what if the fault is in the producer? What if the producer scrambled the order of the messages? So, and this time is when I'm going to shock you. You're going to see UML in DevOps. Yes. You will see UML in DevOps because it is one of the best ways, I know, to... I just lost something. No, I don't. Is it this one? Yes. So normally the calls should go like this. The requests come in. Client goes to P2 from here onwards. Right. So requests come in a certain order, and then what happens afterwards, you have to reach into some API call to do some network before you send your message. This is what happens over here. Zang, zang. Now, let's see what happens if I do this. Almost. I lost it. Client sends exactly up to here, there. Now, green came in, and the green did a call in the network that took longer than the blue took. So while green was waiting for the response from HTTP, blue came in, beep, beep, zoom, out. And then the green, where was I? So they came in green, blue, they went out blue, green. Simple, right? You just scrambled the order of the messages, right? Now, there is a glitch here. You are usually reaching over network in an API for two reasons: to validate the incoming message or to enrich the message you are about to send, right? Now, I am telling you that this is risky, but I do want you to validate the incoming request synchronously before you send it into the async hell. Validate anything before, as much as you can locally before firing the message, because later it will be much harder to recover, right? So, yeah, basically the messages get sent in the different order. Now, what can you do to fix this? You could attach a sequence. The moment you see the request coming in, stamp it with a sequence or a timestamp, and then somehow later on solve this issue, reorder them somehow. You could also ask consumers, please, could you please delay retry? Or you could play like that. You could play like, depuis-moi le déluge. Here are the messages, handle them. They are scrambled, I don't care. You could also play that card as well. And there is another solution to the problem, which is to dive more into the event-driven mindset. And instead of doing the call here, doing the call in a follow-up processor. So you're going to push the messages as fast as you can into the queue, and then set up a processor that will listen on that. And if you do correct partitioning, the order should be preserved. In one thread, you take the message that was sent, call the network, push the next message out. And then because you are on a single freaking thread, you get the next message, you see? You process and you send. This is more event-driven if you want, right? But it does involve one more topic. Yay! Right? But that's one way to put it. You are still not safe, to be honest, because things can go wrong. You see? I mean, things can, by act of chance, there's some delay, and you might actually get to send out after. It's multi-threading. You don't know what happens, but the chances are less. Today we are not scientists. Today we are engineers. Every protection we will set in place here, in any way, is going to complicate the code. It's going to make it harder to maintain and test. So it's a trade-off there. Now, there is a funny question here. What am I sending? Is this M2 a command or an event? This is something new. When you come from REST, in REST, you just code stuff. Here, a message can have two diverging meanings, can be a command or an event. So imagine the following e-commerce scenario. Payment service, when the payment is confirmed, the order must be shipped. How would you model that if you want to involve a robust message on a topic or a queue? How would you name the message? How would you name it if it's an event? Payment received, payment accepted works well. How would you name it if it's a command? Not pay. It should be in the bounded context of the other guy. Ship the order, son of a... You're going to ship the order. Now, the timing. The events are, of course, in the past, whereas the commands are something in the future asking you to do something. Therefore, the sender of an event has no expectations. They just tell you, this happened, take it or leave it, right? Whereas when you send a command, you expect something to happen. Fun. Now, can consumer refuse the message? Okay. Can the consumer say, this is crap? Well, you could do that if it's a command, right? Because it's technically asking you to do something which is impossible for you to do, and then you just say, no, that's an invalid request. Make sense? Whereas in history, you cannot say there was no Beatles. You cannot say there was no... It's history. You cannot refuse history. That doesn't mean you might not fail, but you cannot really blame the event. Technically, there could be a bug in the producer, but conceptually, that's a fact that has happened. You cannot say, no, that didn't happen, right? How many consumer groups listen to a command? One, of course. That's shipping service in this case. And for an event, multiple. Now, we all hope to have many subscribers, right, to be useful in life. And architects love events for this, because we could tap more listeners with no change to the original architecture. Isn't that right? That's what we hope, until the listeners come begging to the producers asking, please, add these 3 more fields just for me. There is this tension of them asking more fields into our events. And also fun, zero. What do you mean zero? Can it be that I publish a message that no one cares for? Perfect. In Google, there is a secret repository. They call it the loose ends repository, in which anyone can publish some stuff, even if today they don't know what to do with it. Who knows what LLM quantum computing will figure out the trend, the connection between me doing some steps and me going to the bathroom. Who knows what we can infer tomorrow? Just push there anything you have interesting. Right? It's this, because we know that whoever owns data tomorrow will rule the world, right? So just fire up information about things, we'll figure out later. Disk is cheap, just fire in the hole, right? Now the real story, political story, is who owns the schema? Who says yes or no, I want to add this field to my message? If it's a command, who owns the message? The receiver. If it's an event, of course the publisher. Right? So producer will listen to the needs of the consumers, but ultimately the producer dictates. The payment was completed. Bingo, that's my order. And that also provides a way of decoupling my mind. If I'm working for payment, I don't care about shipping. I'm just doing my stuff, speaking my own terms, firing the event, take it or leave it. I don't have to orchestrate the flow that happens afterwards. That's the theory. Now let's see the reality. Check order in SAP event. Huh? What the hell is that?
Brother,
It's a request with event at the end. Beautiful. You know why? Because they heard events are cool. Because they want to do event-driven architecture. I'm not sure if you know this joke, what event-driven architecture comes from. EDA comes from that you attend to an event like this, you drive home, and the next day you do architecture. Event-driven architecture. Oh, how cool things we heard. Let's try them out. I attended the other talk today about cognitive biases. You're going to fall into shiny object syndrome over there. The point is, what do you think about this? Order needs payment. We call this passive, not me, Martin Fowler called this passive-aggressive event. I'm not asking, I'm just saying this order needs payment. Right? It's in disguise, you are hiding this somehow. Right? That's also, but what I see most of the time are things like this, order event. Now tell me, what is this? I hope really this is not a request to create an order. I'm pretty sure it's not a command, it's an event, it says there event. But what does it mean? It means that the order was created, or updated, or both, or deleted. If the payload is null, we call it a tombstone, in Kafka. That means that that order just got destroyed. What is this madness? Some of us prefer type equals CUD. Beautiful. That's why some people call these events CUD events, not CRUD, CUD, C-U-D, CUD event. That event can mean any of these things, right? But it's still, you have to ask before you understand what they mean. Back to prod. You receive a notification. They tell you that the credit was updated event, giving you the ID of the SIM. What should you do next? Probably. You want to get the new SIM credit value. So you're going to get back to the producer asking them, give me the credit limit, please. Well, what's the credit now? Have you ever done that? You received an event and you called back to the producer to fetch more data. Let me hear it. Ooh, oh, that's like 50, 30 people. Interesting. What can go wrong? The producer is down. Nice one. Evil one. The producer is down. They've changed it again in the meantime. Exactly. Now, we're going to discuss 3 types of races, but what I want you to know from now is that the solution to this problem would be to attach more data to this event when you send it out. That's called event-carried state transfer. Martin Fowler coined this term. So you're going to start adding fields to your notification. That turns your event from a notification into event-carried state transfer. It's a different species of event. You are moving data, and Martin Fowler wanted to contrast this with REST, that is the typical way to get data. You are now going to get pushed data. Fun. Next thing you know, you have event schema, version 73. Real story from one of my banking clients. They had 73 versions for the same event. Wonderful. Now, consumer calls back, but they are too late because in the meantime, so someone added €5, you got that message, you went back to get the data, but by that time, the credit was updated again, and you received 12. Not 5 like you expected, 12. They've added 12 on top, right? You never see the intermediary state. Now, that could be okay because in architecture, all depends. Could be just fine to miss the intermediary state, but it could be a drama if I was planning to grant some bonus for every recharge of more than €5. If you were planning to see the delta that was added, you never see 7. You never see the 5 added. You only see added 12. So in some circumstances, that can be a little drama. Okay? Why does this happen? Because the producer is firing messages at a very high rate, or the consumer is lagging far behind the producer. Why would that happen? Another war story. At 5 a.m. in the morning, Amazon sent a batch of updates for all the pending orders this company had. They sent 10,000 updates for the orders that were pending. There was a processor that was looking into the file from Amazon, parsing the file, firing 10 million events into the broker. Kafka said, okay, and pushed this tsunami of events onto the consumers below. Guess what happened? We saw lags of half an hour after they were still digesting. That might not be a problem if they don't call back. If they call back, you might see a little bit of, this is the famous war between the batch-oriented world and the event streaming world. There is a file of XML, 2 gigs there, and there is Kafka over there, Rabbit, whatever you have, SQS. And then you're scanning and firing, right? This is a point of care. Point of care. Good, now, 2 scary stories. The consumer came back, but there was nothing there yet. How the heck can that happen? Let's see. Zoom in. All right, so the producer did the update, right, and then commit in its database. And in between, they sent the event. What happened next? Can you guess? Rollback would have happened, but no, everything was well, everything was fine. Not a problem with rollback, no. Message got processed. The consumer called back before the producer ever got to finish and commit. So a new connection was established that didn't see the data in the database thanks to transaction isolation, and the producer answered to the consumer, what data? It's not there yet. This is freaking scary. This is one of the problems here that they send the event before committing, right? That's one of the issues here. You don't send the event saying you're done. A better answer was yours. What if the commit failed? We're going to talk about that in a moment, right? So, another story, the same style. This time I have to UML again. Here. This is again absolutely insane. But the point is they are now sending the event after the commit. Everything works well here. Callback causes the consumer to come back to the producer. But then, surprise, because they are using CQRS, the producer is reading from a DB replica. Could be Mongo, could be Redis, could be a cache, which is a bit lagging behind. So that replica didn't get yet the updates. So you are racing with the replication mechanism. Normally, replication between databases should be very fast, but who knows? Perhaps you played Kafka with your replica as well. What then? It's a very dark, you see my point? Right? So all of these problems will be solved if you just attach more state into the event, remember. Right? Event, carried, state, transfer. Fun. Let's zoom in on the consumer a bit. Consuming a message means you technically have to acknowledge that you've successfully processed the message back to the broker. So the message is then safely considered done, and you will never see it again. Now, what if you had the database in-house? What if you had to do the updates in the database? Where would you do the updates? Would you do the updates after acknowledging or before acknowledging? What would be the default? What do you want to see as the default? You would hit my database before or after? Before, at least once. Before. If you hit it, why do you hit it before? Because there are more chances for a database to fail than Kafka to be down in that instant, right? There are so many ways the database can be down. So if you do it before, then what happens if the update fails? Well, acknowledgement never fails, never goes through. You're only going to get to see the message again. So this is at least once delivery. This is at most once delivery. Make sense? Done. Right. Now, if any one of you is lucky enough to work with Kafka, this problem can be easily solved because you don't have to acknowledge the message back to the broker. You can just store in your own SQL database the offset that you are at. And when you recover back, you atomically persist where you left. You see the point? There is no inconsistency possible between the two. Research that. So, now that we know this, let's look at this particular example from one of my clients. They were using, I think there was a Rabbit listener, no, Kafka listener, but anything on that list works. And they started processing the message in another thread. What can go wrong? Just in case you want more UML, this is the equivalent. What can go wrong? Easy. Start small. The failures, errors, again, what else? The acknowledge goes before you actually process the message. Failures are the first thing we should be thinking of. What if they fail? The message seems to be acknowledged on the broker level. Bonus, if you attended yesterday my deep dive, you saw that if you do completable feature like that, the exception is not printed in the log. If you remember. Anyway. What if there is a power crash? You just took the message into a memory queue and attached a bunch of threads to process from that memory queue. What if there's a power failure? Or Kubernetes decides to kill you? Why not? Anyone got killed by Kubernetes for no real reason? Yeehaw! Oh my God. Like what, 10% in the room? Fun. So, messages can be lost on crash, but then you can say, Victor, we do not crash. This is Sparta. We do not crash. We are strong. Remember, but at exactly 5 a.m. in the night, there is a tsunami of 10 million messages heading towards you. What is going to happen? Because you acknowledge the message immediately, and you don't want to get Kafka mad. Kafka, oh, you acknowledge. Here's 10 million more. So they're going to take you down. Fun. Once a year. Fun. Producer. The famous problem, I want to send an update. Now, you receive a request. The first thing you do, I told you, do not do anything asynchronously before you validate the payload itself. Do I have all the required fields? And that's actually a big problem in a choreographed environment. You don't know what all of the downstream systems are going to require of the initial. It's a dark story there. You might not know what system number 4 requires. You don't even know about that guy. He just listens to events that you fire in a chain. But when you receive a request, you validate the request. Okay, what next? You save something in the database, because why not? And you want also to send a message. What is wrong in this picture? Again, order. We saw that. We saw me firing a message and then right into the database, someone said failures. Correct. What if they fail? Database can fail for so many reasons. Do you know the song? I shouldn't do this. I should not do this. I should not do this. I should not do this. Victor, don't do this, please. Can you hear this?
Do your own electrical work. Teach yourself how to fly. Eat a
3, 2, 1, and.
Don't waste your time. So many don't.
Wonderful video to play your children, not to know not to put the fork in the toaster. I used to do that when I was. Anyway, so I'm going to flip the order, like you said very well. So we have save and send. Now, for some mysterious reasons, someone then adds to this. Oh, no. This actually right now means you've committed and then sent. What can go wrong now? Not rollback. If you rolled back, you never got to send. There is an error. What else? The send can fail, but broker doesn't fail. What do you mean? Wait for the end. You're going to see something fun. This is the dual write problem. This, right now, is not fully atomic. Messages send at most once. In some cases, could be just enough. Really, now. If over the last 5 years, the Kafka broker only went down once, really, that should be just enough. Now, if, however, your message involves money, transactions, payments, would you bet your salary that Kafka broker doesn't blow? So you're gonna transactional. Now, you could put transactional on the top for 2 or 3 reasons. One of the reasons is that you wanted to do one more save. And then you want to turn the whole method atomic. Make sense? 2 saves means transactional, done. Or maybe you are a fan club of ORM and you want to use some Hibernate magic, lazy loading, Kung Fu, whatever. The only thing I don't want to hear you saying is that, oh, I put transactional, so the save and send are now atomic. That is an epic fail. Unless you're still using two-phase commit. Some of you in the house can do GTA, Java Transaction API, distributed transaction, good stuff, old stuff. If you're still, it could still be in order to use. I just met a bank 2 weeks ago that is doing that through some IBM queue and not Oracle queue. I don't know to explain that. But they are doing it. It's atomic save in my database and send. Right. But the funny thing that happens if you put transactional on the method is that the commit in Spring happens after you exit the method. Spring and Quarkus, and EGB the same. They will commit your transaction to the database after you've exited the method. So the message is out. Goodbye message. Goodbye message. And then let's commit. Boom, unit constraint violation. And if you are in the game with ORM, ORM might flush the changes to the database only after you exit the method. It's called the write behind. Right? So, damn it, my inserts are going to wait to me to exit the method. The rabbit is going to take the message and leave. And then I'm going to try to flash my updates. Oh, God. So what do we do? Spring Club can do this. Application event publisher, and then listen for that event back after the transaction within which it was sent was successfully committed. That's very hard to speak. Okay, so you file that event in some transaction, whatever it came from, only when it's committed, you get the event back and you send it over there. Now, if you are in the payment business, this can still fail. Huh? In between, it's in memory, there is a fraction of time between the commit and the send, which can still fail. Now, if you are sick of the Spring magic, extract these things in another method, make that transactional, check that the commit happens before you send. Right? But if you are in the payment business, you want to make this robust, oh God, this is embarrassing. Oh no. So what you do, if you want to make it fully robust, you will persist the message into a table in your own SQL database, commit the whole thing together, and then come up with a scheduler, every second, that looks in the table to see if there's anything to send. If there is, try to hit it. Afterwards, mark it as done. Anyone in this big house ever did that? Did you realize you were actually implementing a message broker? In-house, right? You had over there your own rabbit, much worse, but your own. And then you had to solve the problem of multiple pods racing with each other. You went to Shedlock, Quartz, all the kung fu that you could imagine. We are actually re-implementing the message broker. Right? So, or if you're in the game of Kafka, you can use cdcdbesium to fire the row in that outbox exactly as a message in Kafka. Just click on that link, it will take you to that. This can fail, though. The broker might time out. You might fail to update back in the database, and you will get to send messages twice. Do you see this? If there is a failure in the sending, just exactly in this area, any failure here, or timeout or fail to update, is going to not mark that row as sent. You're going to send it again. And that exposes us to duplicate delivery, right? Because producer just did that. Maybe they are kind enough to add a certain identifier to all the messages they keep retrying, so that the downstream consumer has a chance to dedupe the messages. Maybe that he's kind enough. Or maybe he even gives us a sequential number. Oh my God, how lucky could you be? Huh? Anyway, so there should be some identifier that the consumer can tell by if it's a duplicate or not. That should be in the design of your systems from day one. Now, what if the consumer failed to acknowledge? You're going to see some examples in the following slides. In that case, the message is going to get back to you, right? So, as a rule of thumb, guys, we all know probably already, you should be designing idempotent consumers from day one. So, welcome to messages. Do you know what idempotency means? Let's practice, right? Now, how do you design these consumers idempotent? First of all, you don't do any API calls to change things before you validate if it's a duplicate. Make sense? You don't post, let's create an order. Wait a second. Let's first see if the message is a duplicate, right? And how can you do that? Well, you could use an extra information within the message, like idempotency key. There is a fun practice you could start using. Imagine someone tries to place an order. I'm saying here to add an idempotency key, the same number to the messages you sent. What if the client, the sender, is allowed to generate the ID of the order? So the client over there creates a UUID for the new order to be created, puts it in the message. The producer takes the message saying, oh, look, it's a new order with this UUID. Tries to insert. If it's a primary key violation, it was a duplicate. Done. So this idea of client-generated IDs can save the day here. Or maybe the credit comes with a value that matches the one you tracked in your own database. Maybe you keep track of the state that was the credit amount. And if you see credit updated bringing the same value like you had in your own database, you say, wait a second, it was already 8, right? And you can just return saying, duplicate. Right? Or you could use sequence number for this as well. Now, a bit of design here. You see that there are two species of events here. Credit added, credit updated. Now, we call them delta events or snapshot events. Delta events bring the change. Bring the change. How much was added? Consumers must dedupe. If you process this message twice, you're dead. You're going to add twice the same value. You're going to end up adding 10. Further, the customers, to tell the current state of your credit, they have to keep track of the old state, previous state, to apply the change on that value. Make sense? Do you follow? So it was 8 plus 5 means 13. Simple. But the darker problem is that if you expose such events to the consumers, you're going to have to expose a lot of other types of events. And you can overwhelm your consumer with the semantic of 10 types of events. They just want to know the new credit. Why are you flooding me with events? This discussion gets very dark. We can start talking about the distinction between internal events in an event sort system and external events to the other bounded contexts, to the other teams around that event sourced system. There should be a difference between what you keep as source of truth and what you tell others. Anyway, errors, finally. Errors don't happen. Not to me and not to Chuck Norris. Or errors don't happen. Chuck Norris happens to errors. Huh? So, good. One of my clients expected an hour message, but an ops guy put a JSON in the topic. But you know what happened? Yeah, boom. But what? By some act of chance, the listener in Kafka blocked that consumer forever. The consumer was unable. Normally, the consumer, after 10, 5, 3 attempts, whatever, drops the message. No, this one just kept retrying infinitely. Good. They are in the room, but I can't tell more. Sometimes skipping a message might not be the best idea. If there is a message that you fail to process called fraud detected, you'd better not just drop the message in some dead letter somewhere and continue with more things. I really hope you don't do that, right? Because that is the blocker you have to manually fix before you proceed. More stories. One of the largest e-commerce platforms in Romania, got once a message that an order was placed containing 1,000 different product types. It's not 1,000 items. Those son of a, they've added 1,000 different types of products to the same freaking order. What they were doing in their Rabbit listener was trying to fetch all the products in memory. Guess what happened? That message failed to be acknowledged, and that message was then retried on the next consumer in the group. Next consumer in the group went, that's called the poison pill. If you want to try it yourself, try to do a system exit in your consumer, see what happens. Yeah, not in production. Okay. Poison pill. Another poison pill I've come into contact is there was a message for which the consumer was hitting an API, but that message contained some sort of information that made that API take 2 minutes to respond. 2 minutes to respond. 2 minutes to respond is too much for Kafka. Kafka considered the consumer dead, took the message that was failed to be processed on to the next consumer, boom, 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 with endless Kafka rebalancing as well as a bonus. Beautiful. And for extra fun, when it gave the message to the next consumer, that started working on it while the first one was still working on it. They were racing each other. Freaking insane. So how do we handle errors? With sync retry, with delayed retry, we ignore the errors. If you're doing averaging of temperatures in a room, you could be safe to ignore a bunch of messages, but not for 2 weeks. For 5 minutes, for example. It's a problem, you can't part. It's okay to drop some messages. Log them. Still, what is the problem of logging as a JSON the message in your log? Any problem? Privacy. Privacy and size. One of my clients had a very large message. It basically ran out of quota on the disk. Insane. Send to their letter Q and raise an alarm. And maybe if it's business interesting, you can send another error event. Payment failed. Why? Because la 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 la. Good. Ooh, this is beautiful. In event-driven architectures, services listen to events fired by upstream systems. That's what we call it choreography, not orchestration. We tap into the previous one. What if one of the systems in the chain forgets to publish? Guys, this is not an error. This is me forgetting. There is an if statement that when goes wrong, and I forget to publish. There is no log error, nothing. The systems behind will never hear anything. It's a complete radio silence. Wonderful. How do you handle that? Because some customer applied for a loan, requested a loan, and you never got back to them, right? So what you should do, we could and they've put a watchdog. This is the image AI generated for a watchdog. Every presentation has to have an AI image, that's mine. So 1 week after they submitted the loan request, there should be an alarm if there is no outcome of any kind. Now, another word story is that E was in charge of sending some governmental reports for some potential fraud things. And E wanted to make sure they don't go into trouble, and E was listening to events from D. What E asked D to do is to send heartbeats to tell if they are still alive. If what you do in such a chain reacting to events is critical, you might ask them upstream to send you heartbeats to tell you that they are still there. One last story with cheese and we finish. Cheese paper. Cheese paper. Cart service received a request to add mozzarella to cart. Fired an event, cart item added. And promo service had the following rule. If you add an item of type cheese, you get free cheese paper. Promo granted. Cart item returned with another event, but nothing happened in the future. Until one guy set the cheese paper type to cheese. In which moment, the Kafka cluster crashed, 20 minutes downtime for every system in their ecosystem. Fun. Now, I do have a dream. Do you know what transparent is? Trace IDs. Very few of my clients are in the habit of attaching these traces to the messages they send. What if you did send them and you would see the same trace parent going on and on and on through the same message? You could detect these loops automatically. Summary. This is me dreaming. Summary, top 10. Consumer raised, changing over each other. Out of order, we tried partitions, we tried sequence number, we tried delayed retries. And that's, by the way, the slides. If you want to scan those, that's the slides. Producer races, rushing to publish, but scrambling the order in which they send. Consumer calls back the producer, but the data is not yet there or already changed. Consume and update in a robust way. Update and produce in a robust way with outbox table in CDC. And there are duplicates, so you need to design your consumers idempotent. And messages are the command or events. There's our snapshot. Snapshots are easy to retry until they're done. And error handling, we talked about infinite retries, poison pills, broken chain, watchdog, and heartbeats. And I'm out of time. And I apologize for that. Thank you very much for your time and wish you a wonderful conference.